would like to interview Jan Vitek, who, during the conference FedCSiS 2017, presented data analysis for the masses. Hello.
Hello, it's a pleasure to be here.
Well, you said that about 76% of data miners prefer language R. Why? Can you tell why is that so? Is it any better than all those other solutions that you presented?
Well, R is a tool. It's a useful tool, but it's also a collection of statistical methods that have been contributed by statisticians and computer scientists over 20 years. So today, there are over 11,000 open source packages, and each package contains, statistical methods, visualization methods. For instance, to give you an example, one package may be the random forest algorithm, and another package may be a neural network package. And so there's this wealth of software that is well documented, that is tested and maintained. And this makes R a platform for doing statistical computing. And the other reason, so this is one important reason, the other reason is that R is open source. So both the environment itself and the methods developed on it can be inspected by the scientific community, which is often not the case. So if we compare, for instance, with commercial environments, FedCSiS, SAS, their methods are not always open to the public. Third, it's free. And that is an appeal, clearly, because educationally you can get it at no cost. And then you can, once you've learned it in a university, it's easy to take it with you in your company and keep working on it. To give you an example of how it's used, I visited, a few years ago, I visited Netflix. Netflix has a team of, at the time, I believe about 30 data scientists, and most of them were prototyping methods in R. And then the development process at Netflix was that those prototypes would then be, the ones that they retained, would be recoded by developers in Java to run on MapReduce on the whole data set of the company. But the choice of R was because it gave them very quick turnaround, the ability to experiment quickly, and it was familiar to the statisticians.
Okay. At some point during the presentation, you underlined passing value into a function as something, I would say, a value added from the R language. However, for an IT specialist, for a programmer, this feature is nothing new. It's typical for, let's say, language C.
So the difference and the point I think I wanted to make was that in R, when you send values into a function, logically they are copied. And this may mean that you're logically copying a gigabyte of arrays. As far as you're concerned, whatever happens to that function doesn't have to matter to you. And this is not the norm, say, in C. In C, we pass value by reference. So if I pass a gigabyte of data to a function, that function may change that data. And this is not allowed in R. And why is this a good thing? Well, it allows you to reason about, code mathematically. When you call f of x, you don't in the mathematical setting, you don't expect x to change. So it reduces the number of bugs.
Yeah, but at the same time, I'm thinking about it as bringing solutions that were exclusive for very small number of people, I mean programmers, to much wider group of people, to the masses, as you entitled the whole presentation.
Well, so I think that what R does here is they made a choice, right? They made a choice that was in favor of correctness and ease of development, and maybe against performance. Whereas in lower level languages, languages that are for computer scientists, we tend to make the choice in favor of performance and leave correctness as something you can build on top. So in some sense, R is less general because it's much harder to be performant in R, but it removes a lot of errors, and that's a choice in the design.
Okay, and you showed that data can be quickly cleansed and processed with R, just with the help of a few lines of code. Are there any, I would say, graphically controlled tools that replace that code from the side of the user so that you do not have to actually write those lines, but just fill in some forms and get the result?
So R is definitely sort of and strongly a command line environment, and this was a choice that was made all the way back when S was designed in 1976. They sort of wanted a programmatic environment, and all of the sort of the higher level graphical user interfaces were not part of, you know, their mindset. Nowadays, people are developing higher level tools. So for instance, there is a free open source R development environment called RStudio. And RStudio is adding different bells and whistles. And this is completely conceivable that there somebody would develop as a plugin to these tools. But the truth is that it's difficult to cleanse data, and often you know, the richness of a programmatic environment is something that you often need. So there's only so much you can do with a graphical user interface. I don't know how far one can go, and I think that would be an interesting thing to look at.
Okay, and well, big data analysis involves using big, I would say, multi-core machines. And you said that R is having troubles with parallelism, for instance. So how does it maybe handle such computers? Is performance in such environment strongly affected?
The short answer is definitely yes. So R was designed for small problems, for precise, intricate statistical algorithms working on small data on a single core. Now, this said, over the years, people have tried and explored different ways to parallelize R. So one well-known way is to just sort of develop a package that is parallel, say, in C, and give it an API, you know, from R. Another way that people have experimented with is to have parallel for loops. So you have a for loop that performs an action, and we can parallelize that. And then people have also experimented with forking the R process for coarse-grained parallelism. The thing that R cannot do yet is fine-grained, you know, lock-based shared memory parallelism. And that, in some cases, is exactly what you need for performant algorithm, and for those, R will not be the right solution.
Okay, thank you. And so maybe in the end, during the presentation, a number of times you maybe mentioned that this ecosystem, the R ecosystem, is meant or addressed not at the computer scientists, not the IT specialists, but at all the other people. So how do you think, where is it all going? Are we going to, we as the computer specialists, programmers, are we going to lose that field, the business intelligence field, or not?
Well, I think that we never had that field in some sense, because what do you know about business? What do I know about business? Probably very little. What we can provide, where we can, have added value, is efficiently implementing some solution, is coming up with better algorithm once you have decided what you want, is providing abstractions. That is where we add value. But what we can't do is, come up with a domain-specific solution to a particular problem. And for that, we want those solutions to be mass appeal. We want everybody in a company, in a research lab in biology, to be quickly able to experiment with data. And then when they face problems, and they always do, right? Scalability, time, then they call us. So I think it's a synergetic. The more people are working with computing, the more jobs there are for us, right? So I think this is all good.
Okay, so thank you for conversation.
All right, it was a pleasure, thanks.